Hey everybody, today we're looking at biconditionals and good definitions. Start with the definition of a biconditional. It's the conjunction of a conditional and its converse, and is true when both conditionals are true. Now when we use the word conditional, we're talking about conditional statements, if-then statements. And remember that a conjunction is when you take two statements and you combine them with the word and. Let's look at how we create a biconditional statement. If a quadrilateral is a rectangle, then it is a parallelogram. If a quadrilateral is a parallelogram, then it is a rectangle. You can tell that these are converses of one another. They're both conditional statements, but we've switched the if and the then parts. Now, if we combine these conditional statements into one statement, we get the biconditional. A quadrilateral is a rectangle if and only if it is a parallelogram. Now notice how we write the biconditional. Instead of writing the two conditional statements combined with the word and, we use the phrase if and only if to combine the two conditional statements. Is this biconditional statement true? Well, a biconditional statement is only true if both the conditionals that make it are true. Let's look back at the two conditional statements. If a quadrilateral is a rectangle, then it is a parallelogram. Well, that's true because a rectangle is a parallelogram. It has two pairs of parallel sides. The second conditional says if a quadrilateral is a parallelogram, then it is a rectangle. Well, that's not true. There are lots of different parallelograms that are not rectangles. Therefore, the second conditional statement is false, which makes the entire biconditional statement false. How do we dissect a biconditional statement? Here we're given the biconditional statement that states an angle has a measure of 90 degrees if and only if it is a right angle. Well, we dissect this biconditional by breaking it into the two conditional statements. First, if an angle has a measure of 90 degrees, then it is a right angle. And second, if an angle is a right angle, then it has a measure of 90 degrees. Basically, you're just taking the conditional and reading it from left to right and right to left. Did you know that biconditionals make great definitions? Let's take a look. The definition of a square. Written as a biconditional states a quadrilateral is a square if and only if it has four congruent sides and angles. Let's look more closely at this biconditional definition. Let's break it down into the two conditional statements. If a quadrilateral is a square, then it has four congruent sides and angles. If a quadrilateral has four congruent sides and angles, then it is a square. We can see that both conditional statements are true, which makes the biconditional definition a good one. Let's take a look at another definition. Acute angle. The biconditional definition states an angle is acute if and only if its measure is less than 90 degrees. Breaking this down into the two conditional statements, we get if an angle is acute, then its measure is less than 90 degrees. If an angle measures less than 90 degrees, then it is acute. Again, both conditional statements are true, therefore the biconditional definition is true. Next, we're going to look at some of the rules of logic using biconditional statements. Specifically, we're going to look at the direct and the indirect arguments. Let's start with the direct argument. A quadrilateral is a rhombus if and only if it has four congruent sides. Well, we're going to break this biconditional statement down into P and Q. So we have the first part here that we would call statement P, and we have the second part here that we would call statement Q. Now, using notation, we represent the biconditional if P, or excuse me, P if and only if Q. We use the double arrow to show that a biconditional statement has to work both ways. If P then Q, and if Q then P. Now our second statement says LMNO is a figure with 4 congruent sides. Well, remember, we said that statement Q was it has 4 congruent sides. So if LMNO has 4 congruent sides, then that is statement Q. Finally, therefore, LMNO is a rhombus. Well, we stated that this was P, and LMNO is a rhombus, therefore P. Remember that the direct argument with a biconditional statement can work both directions. So in this case, P if and only if Q was true, therefore we can conclude P. We also could rewrite this argument, P if and only if Q, therefore P is true, therefore Q. It's all based on the fact that the biconditional works both ways. Now let's look at the indirect argument. A triangle is equilateral if and only if it has 3 congruent sides. So again, breaking this down, we can call the first part of the biconditional statement P, and the second part statement Q. Writing it in notation, we see that we get P if and only if Q. DEF is a triangle with 3 different side lengths. Well, statement Q was it had 3 congruent sides. So if triangle DEF has 3 different sides, that's the negation of Q. Therefore, DEF is not an equilateral triangle. Well, remember that statement P said a triangle is equilateral. Here we see the DEF is not an equilateral triangle. So our final statement is written as therefore not P. So this is an example of the indirect argument using a biconditional statement.